So here it is, Milwaukee's new $1,400 torquing impact. Looking at the box, not a whole lot of information, just those standard specs. We move around to the back. Things like normal aren't very clear with Milwaukee, but we have up to 3 times faster install speeds. Yeah, of course it's customizable with one key. And then on this side here, most repeatable torque. Now it appears that this line is supposed to be 15%, and they're trying to show that with your target torque, this tool can come in sub 15 plus or 15 minus. So I guess the question is here, the accuracy and the repeatability. So let's take a look at what's in the box. Just some standard instructions. Yeah, not very much here either. Calibration certificate here. Looks like they just did a target of 150. They did 10 runs. You can see that repeatability limit of 15%. Nice to see. We're gonna go ahead and do some runs and yeah, see what we actually get on the tester. So on the One Key app, you can do the normal stuff. Here we're gonna focus on the torque sense. We have to train the torque sense. So we have application limit. Here you can set it so that it'll alert you to recheck it at 5,000. Then we have progress to service here based on the usage. Last 10 events. So you have 4 modes here on the tool, which correspond to the 4 modes here on the app. We'll select mode 1, change the max speed, bolt removal speed, precision mode, direction lock, and the actual color of the LED. So this is corresponding to on top of the tool. And how bright it is. And then the duration of that LED. So now we actually have to train the torque sense. Again, you're going to select your mode, change the configuration to torque sense. Now, what's interesting with this, you don't have the ability to go up to that 550. It's 50 to 250 foot-pounds. Then you're going to complete 10 training runs. Pretty much straightforward. You're going to need a torque wrench and you're going to need new hardware to do this. We do have some additional stuff here, quick start guide. LED light code matrix, so for errors, low battery, double hit, early let go, stuff like that. So yeah, you don't get this in a paper form, but it is here in the app digital form. So let's go ahead and move on over to the tester. And the reason I haven't tested impacts is because I wanted to look at max torque along with, hopefully this rig will give us actual driving speed of a fastener, while keeping a consistent load on the tool versus something like driving lag bolts in the wood or screws or whatever. All right, so apparently we can't use the tester there because that's a hard joint. You've seen how the torque sense shut it off way too early. But let's go ahead and get it calibrated here with the 10 fasteners. I've got the torque wrench there. Then we'll come back, do another 10. 77.1. All right, so we did the calibration there for 50 foot-pounds, but we'll start fresh there with new hardware and get some torque values. So it is calibrated. We're gonna do another 10. We'll see what each of these come in at and calculate accuracy from there. So this is actually a lot harder than they make it out to be. So after running those 10 runs, we're quite a bit above 50. But that being said, there's some error here. One, we know this is roughly 2% accuracy from testing it on the actual torque wrench tester. And it can be hard to sense when you're actually applying more torque with the torque wrench at that point, which then can, of course, skew these values. Now, ideally, you're using a Skidmore wheel helm because at the end of the day, it's about the clamping force, not so much the torque. When we look at our last 10 events here, it's set for 50 for mode 1, but then it reads the target as 59. Mode 1, target 50. Last 10 events, 50, target 59. Yeah, so this is a bit tricky. Let's move on. We'll go ahead and do 100 here, calibrate it. Then we'll do another run of 10, see what they come in at. Maybe it's just because we're down there at that bottom mark, that 50. So when we talk about accuracy and repeatability here, it's a little tricky in my opinion. Again, they want you to go ahead, do 10 calibration runs with, of course, the hardware you're going to be torquing. As you do that, you're going to need a digital torque wrench because you need to take a reading. That way you can input it into the tool. Personally, I don't think this is the best method to use. Yes, it is the cheapest, but there's a high probability of error because, of course, you need to try to recognize when now you're turning that fastener and record the torque value. At the end of the day, to do it properly, in my opinion, you need a Skidmore wheel helm. That way you can run the bolt down, but after doing so for 50, 100, and 200, keep in mind 50 actually targets 59. The results, in my opinion, weren't that bad considering this is an impact wrench. With the lower end, definitely not the greatest here, but when you do factor that it's trying to target 59, the accuracy improves quite a bit. And as we go to 100 and then 200, yeah, the accuracy improves every step of the way. Looking at max torque, using it as an impact wrench, forward's a little bit lower than spec here with the average of 483, and then reverse, almost right at spec, coming in at 545, using the Forge battery. And the reason I haven't tested impacts is because I wanted to look at max torque along with, hopefully this rig will give us actual driving speed of a fastener, while keeping a consistent load on the tool versus something like driving lag bolts in the wood or screws or whatever. With the driving speed tester, the wrench averaged 8 seconds in comparison to using this hyper tough impact driver averaging 1 minute 28 seconds. So I'm going to do a little more refining on this test stand, but it's going to be interesting to see max torque and also driving speed when comparing impacts. So what's my overall take? Yeah, they designed it for assembly purposes, mainly for the solar industry, but I think this could be used in a production standpoint where you have, say, 4 different types of fasteners and you're currently assembling equipment or machines with a regular impact. No, is it the easiest thing to set up? You know, of course you got to run those 10 runs per fastener to calibrate the impact for that fastener and its respective torque. So ideally you are using a Skidmore wheel helm, which that's going to cost you probably somewhere around $5,000. But overall, I can understand the increase in production with just using this over soft torquing a fastener and coming back in with a regular torque wrench. That being said, no, are you going to get anywhere near this accuracy? But in some cases, you don't need this level of accuracy, but something more than just running it in with a normal impact might be preferred. So at the end of the day, it's really meant for a select few, but from my testing, it seems like it does perform as it should. So hopefully you enjoyed this video. Thanks for watching, and I'll catch you on the next one.